Okay, guys, so let me get ready to share my screen with you all. Today is going to be a pretty straightforward day. We're going to spend the day just working on practice problems involving free body diagrams, or in other words, force diagrams. So using Newton's second law to analyze those diagrams and just look at various situations, because the assignment that I'm going to post for you guys in Schoology will use these practice problems as a model. So be sure you understand how to do these problems here that we are about to work on, because if you have any questions, I need for you guys to stop me and let me know, because this is what you're going to need for your assignment that I am going to post in Schoology as soon as I get done with the Zoom call. Well, about 10 minutes after I get done with the Zoom call, I'm going to post the assignment. Okay, so that's the goal for today. We're going to do these 7 practice problems here, and then we're going to do 2 practice problems here on this worksheet, and then hopefully you guys will have enough knowledge to be able to do the other worksheet on your own, or well, the other assignment on your own. Okay. So guys, remember what a free body diagram is. A free body diagram is nothing more but a diagram that shows you all of the forces that are acting on your object. I'm gonna say that again. A free body diagram shows you show you forces that are acting on your object. And of course, whenever you're analyzing a free body diagram, let me just give you guys just a general thing you want to do. The first thing you want to do, you want to look at the direction of your forces. And guys, and if you guys remember that any force that is acting up, you want to call positive. Any force that's acting downward, you want to call negative. And any force that's acting to the right, you want to call positive. And any force that's acting to the left, you want to call negative. Okay, so just get in a habit of doing that as a general rule. Okay. Also, in order to work out these problems, you are going to need Newton's second law. And Newton's second law of motion says that the sum of all your forces acting on your object is equal to mass times acceleration of the object. So that is Newton's second law. Okay. And remember, guys, this symbol right here, it looks like a weird E. That's the Greek symbol sigma, and it stands for sum. It basically just means add up your forces. So if you add up all your forces acting on your object, then that's equal to mass times acceleration of the object. Okay. And guys, give me just a second while I pull up something on my other computer real quick. Give me just a second. Okay. So now that we have Newton's second law down, let's begin working out some problems here. So look at number 1. Number 1 says find the acceleration of a 2 kilogram mass with the following external forces acting upon it. Well, you know what, guys? This 2 kilogram mass, it applies to number 1, number 2, and number 3. Okay, so Each of these masses are 2 kilograms. Okay, and so guys, notice this free body diagram here. On our free body diagram, we have two forces. We have one force that's 10 newtons acting to the right, and we have another force that's 2 newtons that's acting to the left. So that means this force right here that's 2 newtons, we're going to have to call that negative. Okay. So with that said, let us take this equation here and solve it for acceleration. If I take this equation and rearrange it and solve for acceleration, meaning I'm getting A by itself, then I would divide by mass, and that would go away. Whatever I do to one side of the equation, I would have to do to the other. So that means my equation for acceleration is just sum of my forces divided by mass is equal to acceleration. Okay. So this is the equation we're going to use to find acceleration. Okay. So what are the sum of my forces here? Well, guys, if you have a positive 10 and a negative 2 when you combine them, what do you get, guys? Can anyone tell me? Or anybody want to put in the chat box? When you add up positive 10 with negative 2, what do you get? So the sum of your forces should be equal to 8. So the sum of our forces is 8 divided by our mass. And the mass is 2 kilograms. So 8 divided by 2 is 4. So 4 meters per second squared. That is our answer to number 1. Okay, that is the acceleration of the mass. Okay, hopefully that makes sense. Let's keep going. Now, guys, look at number 2 here. In number 2, notice how we have forces acting in the y direction, but we also have forces acting in the x direction as well. So that means we're going to have 2 acceleration values. So this object here is going to be speeding up in the vertical direction at the exact same time it's going to be speeding up in the acceleration direction. Excuse me, at the exact same time it's going to be accelerating in the vertical. Let me repeat that again. I'm kind of, my brain's getting twisted up right now. So this object is going to be accelerating in the vertical direction at the exact same time it's going to be accelerating in the horizontal direction. Okay, so let's solve for both of them. So we're going to start with the acceleration in the x direction first. So I'm going to put the acceleration in the x direction. Or in other words, the acceleration in the horizontal direction. So remember what Newton's second law says. In order to solve for acceleration, is sum of our forces divided by our mass. So if we add up these forces in the negative direction, that's a positive 12 and that's a negative 2. When I combine those forces, I get positive 10. So I add up my forces in the x direction, and then I divide it by the object's mass, which is 2 kilograms. So 10 divided by 2 is equal to 5 meters per second squared. Okay. So that is my acceleration in the x direction. But what about the acceleration of my object in the y direction? Okay, so remember, the y direction just means I add up my vertical forces, right? Because I want to know the sum of the forces. So if I have a positive 7 and I have a negative 2, when I combine those forces, when I add them, I get a positive 5. Okay, and again, the mass is 2 kilograms. Okay, what's 5 divided by 2? 5 divided by 2 is 2.5 meters per second squared. So this is clearly my acceleration in the y direction. So again, this object here has 2 accelerations. It's accelerating in the horizontal direction as well as accelerating in the vertical direction. And always write down your units for acceleration, which are meters per second squared. Okay. Let us keep going. Okay. Let us look at number 3. Okay. So number 3 is asking us to also define the acceleration in the x direction as well as finding the acceleration in the y direction. So how do we do that? Well, let's start with the acceleration in the x direction first. So the acceleration in the x direction. So let's combine our forces. Notice I have a positive 7 a positive 3, and a negative 2. When I combine all those forces in the horizontal direction, uh, what I get is a positive 8, right? Because 7 plus 3 is 10, minus 2 is 8. Okay, so some of my forces divided by my mass. My mass is 2 kilograms. So I see that my acceleration in the x direction is 4 meters per second squared. Okay. Now, what about my acceleration in the y direction? Now, if you guys notice here, I don't have any y forces here. There are no vertical forces acting on this free body diagram. So if there are no vertical forces, that should be obvious to you guys what the acceleration is. 0 force, 0 acceleration. So for the acceleration in the y direction, it's just 0 meters per second squared. Okay. Everybody got that? All right. Any questions so far on 1 through 3? Okay, let us keep going. Let us look at number 4. Number 4 says the acceleration of a mass is 10 meters per second squared to the left. Okay, so that means we have a negative acceleration because it's accelerating to the left. What is the mass of the object? Okay, so let's figure this out. So remember, Newton's second law says that the sum of our forces is equal to mass times acceleration. So in order to solve this equation for mass, basically I have to divide by A, and that goes away. Whatever I do to one side, I have to do to the other, so that I'm just left with the sum of my forces divided by my acceleration is equal to my object's mass. Okay, so that's the equation we're going to use for number 4. Okay, well, what are the sum of the forces here? So notice I have a force that's positive 2, negative 15, and negative 7. Okay. So guys, if I take negative 15 and combine it with negative 7, that gives me a negative 22. So here, this is a negative 22 here. So negative 22 newtons, right? And that's by just combining these two forces. And obviously, I only have one force on the positive side, so that's a positive 2. Okay. Guys, when you add up negative 22 with positive 2, when you combine these two forces, you clearly get negative 20. So the sum of my forces is negative 20. And notice what the acceleration of the mass is. The acceleration is 10 meters per second squared to the left. So that's a negative 10 meters per second squared for my acceleration. So sum of my forces divided by my acceleration clearly gives me my mass. So in this case, negative 20 divided by negative 10 is just 2 kilograms. Always write your units. So that is my mass for number 4. Any questions so far? Okay, guys, let's keep going. Number 5 says, if mass is equal to 7 kilograms, what is the acceleration? So for this free body diagram right here, guys, we have a mass here that is 5 kilograms. And notice we have forces acting on it. We have forces acting in both the y and the x direction. So what I want to do first, I want to start with the acceleration of the object in the x direction first. And then from there, we're going to figure out the acceleration of the object in the y direction. So acceleration in the x direction, remember, according to Newton's second law, guys, it's the sum of our forces divided by our object's mass. So looking at the horizontal direction first, looking at the x direction. So notice I have two forces here acting in the x direction. I have a positive 16, and here I have a negative 2 because it's acting to the left. When I combine those two forces, I'm clearly going to get a positive 14. So positive 14 divided by the mass. The mass is 7 kilograms. Okay. So that means for the x direction, guys, my acceleration is just 2 meters per second squared. So always write out your units. So that's the acceleration of the mass in the horizontal direction. Okay. But guys, what about the acceleration in the vertical direction? In other words, what is the acceleration of the object in the y direction? Well, guys, notice we have two y forces here. But notice carefully, these y forces are balanced. That's a positive 3, and that's a negative 3. So if you combine that, you get 0 for the sum of your forces. So guys, remember, if we have 0 forces acting in the vertical direction, that clearly means we're going to have 0 acceleration. So my acceleration in the vertical direction is just 0 meters per second squared. Okay. So that is my vertical acceleration, or in other words, the acceleration in the y direction. All right, guys, any questions so far?
Where did you get 14 from?
Where did I get 14 from? So do you see the horizontal forces? This is 16 and this is 2, right? So when you add up your forces, right? Because this is what this symbol means, add up your forces in the x direction. When you combine 16 plus negative 2, what is it? That's just
14.
14. Yeah, that's where that came from. I just add up my forces in the horizontal direction. Okay, any other questions, guys?
And you did the same for the vertical?
Yeah, so I add up my forces for the vertical direction, but notice when you add up your forces in the vertical direction, notice that if you combine positive 3 with negative 3, what do you get? You just get what?
0.
0, right? So that means in the vertical direction, in the y direction, the sum of my forces are 0. So if you have 0 for your force, you're clearly just going to get 0 acceleration. So that's why we had 0 acceleration in the vertical direction, because the sum of our forces was equal to 0. Okay, let us move on to number 6. So we have a mass here that's 5 kilograms, and we want to know what is the acceleration of this object here, and we see these various forces acting on it. So let's look at the acceleration in the horizontal direction first. So the acceleration in the x direction. So guys, look, notice I have a positive 2 and I have a negative 2. When I combine that, what is the sum of my forces?
0.
0. So that means my acceleration is just going to be 0. Same thing in the vertical direction. In the horizontal direction, the acceleration was 0. In the vertical direction, if I have a positive 3 and a negative 3, again, when I add those, my sum of my forces is just 0. So my acceleration is also 0 meters per second squared. All right, number 6 was pretty easy. Okay, guys, we got 3 more problems we're going to do. And then I'm going to let you guys go so y'all can get started on your assignment. Okay, I'm just going over several practice problems with you guys so you guys understand how to do the assignment that I have posted in Schoology. Okay. Number 7 says, sketch the free body diagram for a mass that has a force of 10 newtons to the right, 7 newtons up, 3 newtons down, and 4 newtons to the left. What is the external net force on the mass if the mass is 2 kilograms? Okay, so since we're solving for net force here, well, that's one of the things we're solving for. Remember what Newton's second law says. Newton's second law in its original form says the sum of all of my forces is equal to mass times acceleration. Okay. Now, what it tells us to draw a free body diagram with these forces. So I'm going to do that here. I'm going to do it right here at the bottom. Let me draw a free body diagram. So remember, the problem said that you had 7 newtons going up. So 7 newtons of force acting upward. You had 3 newtons of force acting downward. You had 10 newtons of force acting to the right. And you had 4 newtons of force acting to the left. So that's the free body diagram that they tell us to draw out. Okay. So let us look at the x direction first. So the sum of my forces in the x direction, so I have a positive 10 and I have a negative 4. Okay. When I combine those two forces, I'm clearly going to get positive 6 newtons. So positive 6 newtons will represent the sum of my forces in the x direction. But what about my acceleration in the x direction? So that's easy. Remember what acceleration is. Acceleration is just equal to sum of your forces divided by mass, right? So I just took that equation and rearranged it to solve for the sum of my forces. So if you have, the mass is 2 kilograms. So if the sum of my forces is 6 newtons, 6 divided by 2 kilograms, 6 divided by 2 is clearly 3 meters per second. Okay, 3 meters per second squared. Acceleration is meters per second squared. So 3 meters per second squared is our acceleration in the x direction. Now, what about the sum of the forces in the y direction? So notice I have 2 vertical forces here. I have a positive 7 and a negative 3. When I combine those forces, I get positive 4 newtons. Okay, so 4 newtons. Okay, and my mass is 2 kilograms. So 4 divided by 2 is clearly 2 meters per second squared. So 2 meters per second squared is my acceleration. Any questions so far? Okay. Any questions before I'm done with this worksheet here? Okay. All right, guys. We just have 2 more problems, and I'm gonna let you guys go. 2 more practice problems. Well, we're going to do 2 more problems, and then after that, I want to spend like a couple of minutes going over the possible scenarios with free body diagrams, just to remind you guys of that, so that you all are perfectly ready to do the homework assignment, and then I'm going to let you guys go. Okay, so look at these word problems right here. So it says a race car is initially moving at 85 meters per second, and suddenly it slams on its brakes and comes to a stop. It takes 12 seconds for the car to stop. Assuming the mass of the race car is 1,100 kilograms, what was the force of friction acting on the race car during this interval? Okay, so guys, I'm telling you guys right now, we're going to need 2 equations to solve for this problem here. So the first equation I'm going to write down, it turns out we're going to actually have to go back to our kinematics unit. The first equation I want to write down is the equation for acceleration that we talked about in our kinematics unit last 6 weeks. And remember, guys, what acceleration is. Acceleration is mathematically defined to be final velocity minus initial velocity divided by your time interval. Okay. So that is acceleration. So we're going to need to know this equation. And also I'm going to write down Newton's second law, which says that the sum of my forces is equal to mass times acceleration. So that's another one we have to know. Okay. So now let's plug everything in, guys. So it says, so what we need to do in order to find the force acting on the race car, we need to find the acceleration of the race car first. So, so a race car is initially moving at 85 meters per second when suddenly it slams on its brakes and comes to a stop. And it takes 12 seconds for the car to come to a stop. Okay, guys, if we are coming to a stop here, that means our final velocity is just 0. So we came to a stop, our final velocity is 0. And notice what was the initial velocity. The initial velocity of the car, it says it was moving at 85 meters per second. So 85 meters per second. Okay. Now, the acceleration was over a period of 12 seconds. So I'm going to plug in 12 for my time. So if I do negative 85 divided by 12, that gives me an acceleration. That gives me an acceleration of negative 7.08 meters per second squared. Okay. Now, guys, check this out. The problem says solve for the force of friction acting on the race car. So force is equal to mass times acceleration. Since I know my acceleration here, I can just take this acceleration and I can plug it into this equation right here. So I can plug it into this equation, plug in the mass, and that'll give me my force. Okay, so let's do it now. So force is equal to mass, which is 1,100 kilograms, multiplied by my acceleration that I just solved for, which is 7.08. So when I multiply those two together, guys, I get a value of my force that is negative 7791.67 newtons. Okay. And that is the force of friction that is acting on the race car. So basically, it's almost 8,000 newtons of force that is responsible for stopping the race car. Any questions there?
Can you go back to the first few problems? I just want to see the what.
Yeah. You need to take a snapshot of it?
Yeah.
Right here. And Spencer, I'm going to also post this video on YouTube as well.
Okay.
Yeah. So remember, the link to my YouTube page is in the second 6 weeks folder.
All right. It's like this video or the for the next class.
This one, I'm going to post this one.
Okay.
Yeah. So let's look at this one right here. It says a track runner accelerates from a velocity of 0 meters per second to a velocity of 12 meters per second in 9 seconds. If the runner pushes off on the ground with a force of 95 newtons acting on him, what is the runner's mass? Okay. You know, I'm going to use different colors for this one. Let's use blue. Let's use blue. Okay, so same thing before. We're going to need two equations to solve for this problem. We're going to need our equation from kinematics, which says acceleration is equal to final velocity. Hold on, guys. Give me just a second. Let me kind of zoom in here so that I can write better. So acceleration is equal to final velocity minus initial velocity divided by time. Okay. So that's the first equation I'm going to need. Okay. And I'm going to also need to know the equation for Newton's second law, which says that the sum of all of my forces acting on my object is equal to mass times acceleration of the object. So using those two equations, I can solve for this problem here. Okay. So reading this again, a track runner accelerates from a velocity of 0 meters per second to a velocity of 12 meters per second in 9 seconds. If the runner pushes off the ground with a force of 95 newtons, with a 95 newton force acting on him, what is the runner's mass? Okay. So guys, before we can solve for mass, we need to solve for acceleration first. Because once we solve for acceleration, we can then plug into this equation, plug in 95 newtons for our force, and then that'll give us the mass. So let's solve for the acceleration first. Okay. So remember, acceleration is equal to, okay, the final velocity of the runner is 12 meters per second. Okay. So the initial velocity of the runner is 0. He started from rest, 0 meters per second. Okay. All of that divided by the time, which is clearly 9 seconds. Okay. So guys, if you put 12 divided by 9 in your calculator, you're going to get 1.33 meters per second square for your acceleration. So acceleration is equal to 1.33 meters per second squared. Okay. Now, guys, we have everything we need to solve for the mass of this runner. So, guys, if I take this equation here and I rearrange it and get m by itself, okay. Remember how to get m by itself, guys. So to get m by itself, you're gonna have to divide this side by a. That goes away. Whatever you do to one side, you have to do to the other. So I'm just left with the sum of my forces divided by my acceleration is equal to my object's mass. Okay. So, okay, what are the sum of the forces? Well, there's one force acting on the runner here. It's 95 newtons. Okay. The acceleration of the runner was clearly 1.33. We've already solved for that. And that is equivalent to my mass. So if I do 95 divided by 1.33, that gives me 71.43 meters per second. Let me see here. So my mass, let me write that down here. My mass is equal to 71.43. I'm just rounding to the second decimal place. I'm sorry, 71.43 kilograms. I think I said that unit wrong. So 71.43 kilograms is my mass. If I said meters per second squared, I didn't mean that. I mean kilograms. So my mass is 71.43 kilograms. Okay. Any questions on what we did? So all we did, we just used this equation here to solve for acceleration first. Once we found acceleration, we plugged that in here, plugged in our force, and then solved for the object's mass. Hopefully that should make sense to you. Now, guys, on the assignment that I'm going to post, in addition to working out these problems, you guys need to know how to interpret the meaning of free body diagrams. So let me briefly go over that. So guys, it's very important that you guys look at a free body diagram and be able to tell me what's happening. Okay, so for example, let us look at number 5. Number 5 says this object is moving down. It's moving in the negative direction. So guys, it's moving in the negative direction, but guys, notice which force is dominant. Notice the positive force here is dominant. So remember what I said before. If the object moves in the opposite direction of the dominant force, it's going to be slowing down. If the object moves in the direction of the dominant force, it's going to be speeding up. Let me say that again. That's very important. If the object moves in the opposite direction of the dominant force, it's going to be slowing down. If it moves um, um, if it moves in the same direction as the dominant force, is going to be speeding up. So notice, guys, this object is moving down while at the same time the dominant force is acting up. So in other words, it's moving in the negative direction, so that means this must be slowing down. This object here is slowing down while moving in the negative direction. So that's how you would describe that. Okay. What about number 6 here? On number 6, remember our forces are balanced. So anytime our forces are balanced, Newton's first law holds that if we have balanced forces, the object in motion wants to stay in motion at a constant velocity. Okay. Again, guys, I'm just going over various examples with you guys. Look at 7. Number 7 says this object is moving up, so it's moving in the positive direction. If it's moving in the positive direction, that means it's moving in the direction of the dominant force. So clearly this object is going to be speeding up while moving in the positive direction. Okay. What about this right here? This object is moving down. It's moving in the negative direction. But notice it's also moving in the direction of the dominant force. So here this object is speeding up while moving in the negative direction. Again, guys, I'm just giving you guys various situations here. What about something like number 2, guys? If you see an object that is moving vertically, what does that mean? If an object is moving vertically, that means it could either be moving up or it could be moving downward, right? It could be moving in the positive direction or it could be moving in the negative direction. So, guys, if you got a question like this on a quiz and it asks you what are the possible scenarios, what you would say here, if the object is moving in the negative direction, it's moving in the direction of the dominant force. If it's moving in the positive direction, it's moving against the dominant force. So what you would say here, guys, the possible scenarios here that this free body diagram could explain, you would say this object is either speeding up while moving in the negative direction or is slowing down while moving in the positive direction. Okay. And guys, we saw an example like that, a real world example in which in which one free body diagram could explain 2 different scenarios. Okay. And we saw that because remember I showed you guys this video of this young lady here skydiving. Not skydiving, bungee jumping. Excuse me. So as she's bungee jumping, okay. So at this moment that the cord tightens, so note the cord of the rope that she's connected to, as it tightens, we have 2 forces acting on her. Okay, we have 2 forces acting on her. There's gravity, and you guys know that gravity is acting straight downward. Okay. So there's gravity, which is acting straight downward, but there's also tension from the rope, and tension here is larger than gravity. Okay. And tension is pulling upward. So guys, there's 2 forces acting on Lexi, who is bungee jumping. So guys, notice how this one free body diagram that we drawn here explains 2 scenarios. Lexi, she could either be slowing down while moving in the negative direction, and you know she's slowing down because she comes to a stop. And then after that, notice she starts speeding up while moving in the positive direction. So she's speeding up as she's coming out of the water. Okay. So that should make sense, right? So when she's moving in the opposite direction of the dominant force, she's slowing down. When she moves in the direction of the dominant force, she's speeding up. Okay. Hopefully that makes sense. Any questions? Okay, guys, if there are no questions for me, you guys are free to sign out. I'm going to have the assignment posted in Schoology in about 10 minutes. I hope you guys have a good day. Bye, guys.